Good morning. It's Friday, and I had a student ask me about page 99 on the 3-2 guided lecture notes. And it includes both finding an upper and lower bound of zeros for a polynomial, and it also includes using the intermediate value theorem. And I thought I would just talk through your e-text, and then I would fill out the paper and you could follow my written instructions too, and then I'm hitting people who need to hear it and people who need to see it. So this is example 8 on page 221 of your e-text, and I'm supposed to use the bounds on zeros theorem for this polynomial. And the bounds on zeros theorem, I think it's on the previous page, says if m is greater than 0 is a real number, and if the third row in the process of synthetic division of f by x minus m contains only numbers that are positive or 0, then m is an upper bound. And if they are alternating, then little m is a lower bound. So that's what we're looking for when we do our synthetic division. So I'm back on example 8. It's 2x cubed plus 11x squared minus 7x minus 6. And the first thing we're going to do is use that possible rational zeros theorem, which says I take factors of 6 over factors of 2 and plus and minus all of those. So I have plus or minus 6 over 2, plus or minus 3 over 2, plus or minus 2 over 2. And that gives me this list right here. To find an upper bound, I'm going to start with the smallest positive integer that is a potential rational 0. So these aren't integers, 1/2 and 3/2, so I'm going to start with the smallest positive integer, which is plus 1. And then I'm going to check 2, and then I'm going to check 3, and then I'm going to check 6, because I need that to happen in order for me to find an upper bound. So here is the synthetic division results. So for instance, if I use the synthetic division on 1, I bring that 2 down, and then 2 times 1 is 2, 11 and 2 is 13. 13 times 1 is 13, 13 minus 7 is 6. 6 times 1 is 6, and then I get a 0. All of these are non-negative, which means I have an upper bound of 1. Then once I found, since I got lucky with that one, I don't need to try 2, 3, and 6. Now I'm ready to go to the negative integers. So I'm going to try negative 1. I do synthetic division, I get this, negative 2, negative 3, negative 6. I finally do negative 7, and I do get alternating signs. So that is my lower bound. All that means is on my graph, I know that negative 7 is a lower bound and 1 is an upper bound of my 0. So I will fill out example 8 for you, and you can look at that. The next example is about the intermediate value theorem. In the intermediate value theorem, this is a great picture to look at. It says, if I have a y value that's positive, and I have a y value that's negative, and my curve is a continuous curve, then I'm able to hit the axis somewhere in there. I have a 0 somewhere between there. So basically, I'm just going to plug in a and b and find out if I have a negative and a positive, and then I'll be able to say, well, it's got to cross the axis somewhere in there. So if I look at this example, it says show this function has a 0 between 1 and 2. I plug 1 in, and I see that I get 1 minus 1, which is 0, minus 1, and I get negative 1. If I plug 2 in, I get 2 to the 5th, which is 32, minus 2 cubed, which is 8. So 32 minus 8 is 24, minus 1 is 23, and it's positive. So it looks like I have a negative and a positive, and therefore there's a 0 in between those two.